The arcsine function, written arcsine of x or sine to the negative 1 of x, is the inverse of the sine function. Like all inverse functions, the input and output switch. Here's an example. Sine of pi over 6 equals 1/2 implies arcsine of 1/2 equals pi over 6. The table gives sine and inverse sine values for some first quadrant arcs. There is no more information in one column than in the other. It's simply a matter of switching the inputs and the outputs to get from the sine column to the inverse sine column. So sine of 0 is 0, arcsine of 0 is also 0. Sine of pi over 4 is the square root of 2 over 2. Arcsine of the square root of 2 over 2 equals pi over 4. Arcsine of y equals t. The arcsine y can be displayed on a unit circle. It is aptly named since arcsine y is an arc on the unit circle that terminates at a point y units from the horizontal axis. The idea can be written in a different way, namely y equals sine t. There is no more information in one statement than in the other. It's simply a matter of switching the input and the output and changing the function name from inverse sine to sine. Here are two examples. Sine pi over 3 is 0.866, but you could also say arcsine of 0.866 equals pi over 3. Here we have sine of negative pi over 6 equals negative 0.5, and here we have arcsine of negative 0.5 equals negative pi over 6. The sine function is not one-to-one. There are infinitely many inputs for any output in the range. For instance, sine of pi over 6 is 1/2, sine of 5 pi over 6 is 1/2, and sine of 13 pi over 6 is also 1/2. Earlier, we accepted that sine of pi over 6 is 1/2 implies that sine of the negative 1 power of 1/2 equals pi over 6. However, sine of 5 pi over 6 equals 1/2 does not imply that the arcsine of 1/2 equals 5 pi over 6. There can be only one output for the arcsine of 1/2, namely, the arcsine of 1/2 equals pi over 6 only. To create the inverse sine function, the domain of sine function needed to be restricted to create a one-to-one function so that there's no confusion. There are many ways to restrict the domain of the sine function to create a one-to-one function. By agreement, though, the restriction that is universally accepted is for x between negative pi over 2 and pi over 2. By restricting the domain to between negative pi over 2 and pi over 2, all of the range values are achieved exactly once, making the restricted function one-to-one, and hence making the function invertible. Here are the graphs of the restricted sine function and its inverse. Domain of sine x is equal to the range of arcsine x, negative pi over 2 to pi over 2, and the range of sine x is equal to the domain of arcsine of x, negative 1 to 1. So here we have in red our sine wave, and here we have our arcsine wave.